these problems, you're finding the x and y intercepts. And another name for x-intercept is the zeros of the function. So we'll start with finding the y-intercept of this first function. We're going to let f of x be y, and then we substitute in zeros for the x to find the y-intercept. So when you simplify this, just by adding the right-hand side here up, we get 33. So our y-intercept is, we let x equal 0, and we found y to be the number 33. That's where our function will cross the y-axis. So for the x-intercept, or the zeros of the function, I let y equal 0, and then solve for x. So for this problem, it's a quadratic, so I'm going to look to see if I can factor out a common term first. In this case, there are no common terms. So I'm going to factor by using the reverse FOIL method. You can also use the AC method if you're comfortable with that method, or you could use the quadratic formula if you remember that. The reverse FOIL method, though, is what two variables multiply to give you x squared, and that would just be x times x. Since both of these signs are pluses in front of the b and the c term in the quadratic formula, they'll both be pluses in your factors. And then what multiplies to 33 but adds to 14, that would be 11 times 3 gives me the 33. Double check it by multiplying the outside and the inside of the FOIL method here. So it's plus 11x and a plus 3x. Add up to plus 14x. So you know you've got it factored correctly, but you still have another step to go. You need to set each factor equal to 0, solve for x. So subtract 11 from both sides. And one of your x-intercepts would be at -11. The other one would be at -3 after you solve this factor. So you have two x-intercepts, one at -11, 0, and the other one at -3, 0. And again, it's 0 on the y value because you let y equal 0 when you found the x-intercept. Same idea for part B here. To find the y-intercept, you're going to let x equal 0. And then just evaluate the right-hand side. So 0 minus 0 plus 27 comes up 27. So this is going to have the point, or this will be at the point x is 0, and you found y to be the number 27. X-intercept, right, let the function equal 0. That's why they call it the zeros of the function. G of x equals 0, so 0 equals, and then the right-hand side is something that you're probably going to have to factor or solve for x in some form. And again, I'm going to go ahead and do the reverse FOIL to get the first x times x. Then I look for the last. I need to multiply to 27. The signs have to be the same, either both pluses or both minuses, since that last number is positive. The middle term then is going to tell me whether they're both pluses or both minuses. Since this is a minus, they both have to be minuses. So it multiplies to a positive 27, and -3 times a -9 multiplies to positive 27. But then when I add the middle terms, I have a -3x and a -9x. That adds up to the -12x that you needed in the middle. Set each factor equal to 0 and then solve for x. So add 3 to both sides, we get x equals 3. And do the same on the other one here. X minus 9 equals 0, solve for x. Add 9 to both sides. So you have two x-intercepts, one at 9, 0, and the other one at 3, 0. For letter C, to find a y-intercept, I'm going to let x equal 0. And then just evaluate the right-hand side. So 0 plus 0 minus 60 can be a negative 60. And that's my y-intercept. For my x-intercept, you let the y value, or f of x, equal 0. And then again, look to see if there's a common term that you can factor out. Since it's 3 terms, again, I'm going to try the reverse FOIL method on it, since there was no number to factor out. X times x. The last number now is negative 60, which means the signs have to be opposites. And then you think about what two numbers multiply to 60. You've got a couple of combinations, but keep in mind it also has to add to positive 4. So if I do a positive 10 times negative 6, that'll multiply to negative 60. And if I add the middle terms, a positive 10x and a negative 6x, that'll add to my positive 4x. From here, set each factor equal to 0, and then solve for x. So once again, I get two x-intercepts, x at 6, or x equals negative 10. So there are the points negative 10, 0, and 6, 0.